Welcome back, everyone. In this video, we are going to start modifying our createAction type so that we can set up the remainder of our Redux with the appropriate TypeScript bindings. Now, the first step we need to do is we need to turn this reducer utils from a JS file to a TS file. And what we need to do is actually quite a large amount of work. But as we're typing this out and figuring this out, I'm going to touch upon why we need it. So it's going to be quite extensive. You just need to follow along with me as we go, and it will make more sense as we add in and type out some of what we're going to do. So the first step is we need to import in this anyAction type from Redux. The anyAction type is essentially an interface that extends upon this action type. The action type is just an action interface that has this generic T. This T can be anything. But the idea here is that this T is going to go to some type value. Now, when we go back to that anyAction also extends upon extra props. So any additional properties that you want, some people use actions inside of their project where they actually add their own values. So it's not just tied to type and payload. Sometimes there are some additional ones. But the reason why they use this action as the base is because not all actions have payloads. We run actions that have no payloads as well. So what we need to do is we need to take this anyAction and we have to figure out a way so that we can extend it into our system so that we can utilize all of our surrounding libraries. And this is a very important thing to note. There are many, many ways that you can approach typing Redux. Many different projects do it differently. There are trade-offs in this process. And as people say, TypeScript is an art, not necessarily a science. There is some degree of it where there's definitely best practices and patterns. But in this process, there is also a very high degree of what is correct and what is kind of correct but relevant in the use case. Honestly, all I'm trying to say is that this process is not going to be the most straightforward, but this one that we're going to do, we're going to justify every step that we go. So what we're going to do is I'm going to create two types. I'm going to create an action type that defines our action with payload. So here I'm going to say action with payload. This is going to be our type that takes some generic T and some generic P. Now T, of course, is going to be our type value. And then our payload is going to be P. So what I'm doing here is I'm saying whenever we call this action with payload, this T value is going to be one of those enum values that we're going to pass in. Because as I mentioned, when we did our category types right here, we know that the type is a very specific string. It's not just going to be string, but a very specific string. So I want to be able to pass that enumerable member value and then set that as the type. And then for the payload, well, we can pass in any payload that we want. So that's the first thing. The next thing that I need is the type of action. And action is also going to receive a generic T. And this T, of course, goes to the type. But because we have no payload here, we are just going to remove the need for the payload. Now you might be wondering, well, Yihua, why is it that with this action, we've created two types? Could we not just make this payload optional? And then now we have just one type instead of two? So the reason why this would be incorrect is because if you hover over this payload, you see that this property of payload points either to P or undefined. The problem with doing this is that it essentially says that you have a chance of getting an action where payload is always present. It's just going to point to undefined. While that's true in JavaScript, we actually don't want that to be true in TypeScript. We don't even want there to be a payload in the first place. Essentially, if you get this action where it's just a type, no payload, if you try to call payload, we want to throw actually that there is nothing there. It's an error. You can't even access payload because payload isn't even a property on this action type. By doing this, we narrow the scope. Because if we generate a action where it just has type no payload, then in no way, shape, or form should the code that's using that action ever even try to reference a payload. Because if you do, it's going to be undefined. There's no point of that. And there might be some functionality in the JavaScript world where you use that undefined payload to determine if you should move forward or not because it's indicative of something. But with TypeScript, it actually is the opposite. You don't want that because you get now that type safety. And this is where you kind of have to change your thinking a little bit. The patterns that you're used to before, where it's okay to have something as undefined, does not really run inside of TypeScript. You want to be very explicit. If you have some action that has a payload and another action that doesn't have a payload, those should actually be two different types. So we'll discuss more of this and the reason why we have to set it up this way once we move on to our reducers. But for now, we have to actually do all of this setup. So the thing that we know now is that we have two different action types. We have an action with a payload and we have an action without a payload. Based on this createAction, depending on if we receive a payload or not, we want to return the appropriate action. We want to either return an action with payload type if there is a payload, but if there is no payload, then the type that we get back from calling createAction should just be a regular action. So in order for us to achieve this, we need to do something known as function overloading. So function overloading actually comes from TypeScript, not JavaScript. Function overloading provides us this ability to make multiple function type definitions of the same name. So we can have multiple type definitions for createAction. And what it allows us to do is allow this function to receive different parameter types. It should be the same number, meaning that we should receive 2 if our createAction always receives 2. But what it does is that it can now return different types depending on the parameter types that we receive. So let's write it out and it will make more sense. In order for us to do it, we actually need to use the classic function declaration style rather than the arrow functions. So we're going to convert it over. So to do that, we're going to say first function createAction. This createAction, as we know, is going to get a type and a payload. So depending on the action that we're creating, again, we're passing those constant values. If you remember from our action type right here. These are these fixed values in our enum. So we need to pass that as the t value. But we know this is a string. So we're going to say that this createAction extends string. We're also going to get the type for the payload. It might be anything we want to pass as the payload. And then what we're going to say is that, okay, once this happens, we're going to get some type value, which is t, and we're going to get some payload parameter, which is p. And then all we're doing is we are returning back an object with type payload. So if you think about it, really, this is just the type version of this using the function declaration style rather than the arrow function declaration style. If you were to do this not in TypeScript, you would just get rid of this and get rid of the types. These two are now equivalent, this function and this function, but with the types, it looks like this. So now we have a regular function definition that is typed. But now we need to type define this so that it returns the appropriate type from this. Because right now our function is not actually returning anything. This is more so what the actual code implementation of this function will do. So now we need to do the overloading. So to overload, if you're going to export, you always want to export all of your overload definitions. So again, we're going to type the same function createAction. And here we're going to receive some t that extends string. And we're also going to receive p. So now what we're doing is we're just typing the function the same way, except we're going to make sure we return action with payload. Now we've already defined the implementation part in this last function. We don't need to define the implementation again. We're just going to define the type. So here we know that we extend these values, but we also need to now pass these types into the parameters. So here we're saying, okay, this createAction function We'll get some T of type string and then some payload of P. And then what it'll do is that it just returns back action with payload T and P. So here we're just saying, okay, if createAction gets called with a type and a payload, the return type from this function will be action with payload, T and P being passed in like so. So that's the action type you can expect to get back from this action when it's called with type and payload as parameters. Now what we want to do is we want to type the function if it gets called with just a type. Because when it just gets called with type, we want to pass back an action, not with payload. So here we're going to say T extends string. But what we need to know is that, okay, when this createAction gets called with just type T, there's no P value here. So here we know that we are getting type T. But the thing is that createAction is technically expecting a payload value because it's not optional. So this means that we want to make this essentially equal to void, which means that you are not expecting anything. And then we can just say action type T. Now, if you did not include this, let's say you just did this, you will see that createAction throws you an error because again, it says the overload signature is not compatible because, as I mentioned earlier, in order for you to overload functions, you must have the same number of parameters. So the way that you avoid this is you just say, okay, payload then gets nothing, void, no value. And with this now, you'll be able to create this additional createAction typing on our function. Now, if you hover over createAction, we can receive a payload, we might not receive a payload, but essentially what this createAction will now do, it's hidden behind the +1 overload. It can now spit out either an action with payload if payload is provided, or an action if just the type is provided. This is essentially how you type these functions so that they can return you back different types depending on the parameters and the types that get passed as the parameter. If the payload matches void, so undefined, meaning you did not pass it, then you get back an action. If createAction gets both type T and payload of whatever the P generic gets passed, then we get back action with payload instead. This is now our new createAction type. So we didn't use the anyAction yet. Again, this will become more important a little later, but for now, this is what we've done for our createAction. So with this now, let's move on to our next video where we will try and use this createAction inside of our application. I'll see you in the next video.